higher. Okay. So these are just some examples of the timber structures. These are what we call floor joist, okay? We have here the beam, and then there are floor joists. Floor joist, the concept of the floor joist is just the same with the beam, no? The same lang yung concept niya. They're just the same. Okay, next. And then the timber beam in historic barn, Can River, from this source, okay? This just to show example. Actually, this book, I'm going to upload this book. You might need to have some further reading related to the timber structures. Our what's this? Our source, our reference books will be using this one for some further discussion. We're using a reviewer book from Sevilla because this is the book which was used by the first professor who made the slides that you could already download from the canvas. Right? So I can make some alteration or some additional information, but basically that would be the slides and then the book that we're going to use. I could share it with you as well. And then this some examples of timber structures. And then we have also in steel design, if you have composite type of structures, steel design, you also have composite type of structures in timber. And you can also have, which is similar also to concrete, may composite structure in concrete, composed of, let's say, structural steel and then encased with a concrete. So sa timber, meron din ganito, just like I-beam. Rarely that you could see this one, right? For long span, could use this one. Okay, so this is the concept of having the flexural stress on the beam. Let's say a foam. Pagka there's a concentrated load here, this could be the effect. This could be the elastic curve. This could be the possible deflection on the beam. So may elasticity, may elastic curve siya, no? Ganyan yung elastic curve. There would be a maximum deflection at the midspan, as we have studied it in the strain of materials, because of the concentration of the concentrated load at the midspan. Not only because of the concentrated load, there is also uniform load caused by the self-weight of the beam, and then possibly instead of this concentrated load, there's also a uniform load that could be caused by a certain load. Pwede siyang slab, slab uniform load. Okay? And then if you have continuous beam, this could also be the effect. Okay? So if you are going to cut at the section, this is the effect, for everyone's information. At the top is the compression, and then the bottom is the tension. So here we have the load, compression here, and the tension here. And if you have for cantilever beam, of course, the elastic curve will be doing like this. Okay, tension here, and then compression here. Okay, that's why pag mga cantilever beam, if you have cantilever beam, that is this one is your column, yung cantilever beam. Ang reinforcement niya nasa taas talaga. Okay, you may omit, if not necessary, the reinforcement sa bottom, because primarily the support of the reinforcement here is in the tension side, which occurs at the top section of the cantilever beam. Okay, so that would be the case. You might be wondering why the moment diagram ito nasa tension side. In some books, especially for foreign author books, yung orientation, the orientation of the moment diagram is on the tension side. Okay, so similar to that of the elastic curve, but for our local author and some other foreign books as well, there are some that the moment diagram is this one, and this is the practice of what we are doing. Okay, ito yung practice. Kahit sa mga structural software, let's say ETABS or mas familiar sa structural analysis program, SAP, they're using this. This is the default. Okay, ito yung default na orientation ng moment diagram. But the calculation, the concept would still be the same. Now, as we have seen in the previous slide, for continuous beam, ito naman yung, okay. So as you see here, the positive moment is in the tension side. Pero yung orientation natin, ganyan siya. If you remember in your strength materials, this is the positive moment, and this one is the negative moment, which is at the support. Anyhow, that's still design, okay? Only the orientation of the diagram. Now, let us have a brief review. The general formula for the flexural stress is MC over I, okay? M is for moment, C is the distance from the neutral axis to the outermost fiber or to the location by which you would like to get the flexural stress. In this case, if this is your neutral axis, this is the maximum stress, yung pinaka-top, yung maximum stress, That is C, yung distance from the neutral axis, which is just D over 2. Now, in some cases that you would like to ask, or you would like to know the flexural stress at certain point, at certain point, then you just have to use this C, okay? Let's say the question would say, what is the flexural stress of the beam, with the maximum flexural stress of the beam at a certain distance, let's say 100 millimeter from the top of the beam. So ito yung tinatanong, okay? So that is the stress on it. So you're going to use C. Only here, going here, okay? So that's the point of having this C. Of course, you have the moment of inertia, but you could use this one if you're going to use a rectangular section. Tapos maximum moment talaga nasa topmost fiber ang tinatanong. We have the calculation, wala. We have the calculation. Yung moment, yung C is D over 2 if you are going to calculate. C is D over 2. Okay, and then you have I, which is B, D cube over 12. Okay, MC over I. Okay, yun. Ito, magiging 6. This one will have 2. So flexural stress is 6M BD squared. This one is only for rectangular section. So in other words, if you have section, your section is circular or some other regular section, then you are going to use this general formula. Okay? Am I clear to everyone? Confirm naman. You can, yeah, okay, right. So let us have an example. Actually, this example is just easy. I don't find this subject difficult. I just wonder why there are some students who fail. Nag-expect ako napapasa lahat. Okay? So I would also expect the same from this group of students. Okay? So anyway, start. So for example here, a floor is supported by 75 millimeter and 200 millimeter wooden joist, spaced at 400 millimeter on centers with an effective span of 3 meters. Ayan yan, Medyo hindi lang malabo. Medyo malabo lang. Okay. Ito yung span, ito yung beam kung i-project natin papunta yan doon, Ito yung slab, nakaganon. Andito yung span, which is L. Okay. Ito yung pahaba yan doon. Okay. Ang spacing niya is 400 millimeter. Yeah, 400 millimeter. Okay, the total floor load transmitted to the joist is 5 kilopascal. This load will be coming from the weight, yung weight ng ng slab. Okay? Pero ito, consider yung weight of wood. Unit weight of wood is 6.3 kilonewton cubic meter. So if we are going to calculate this one, then we have to calculate first the weight of wood and then yung one. Nakaharang to. Okay. Okay, so okay. So let's start. So how to calculate? So for example here, so if you consider this beam, if you have this beam, okay? Ito yung beam, masyadong malaki. Okay. Ito yung beam, ano? So. Sorry medyo lang. Ito yung beam. Sabi natin kanina, the span of the beam is equal to 4 meters. Now we are going to identify what would be this load. Okay? What would be this load? Should be W. Okay, so what are the loads? Okay? Ano yung mga load natin? Here, you have the total load transmitted to the joist na 5 kilopascal. If I'm going to draw here, okay. Looking at the top, kung titingnan natin sa taas, ito yung beam, nasabi niya, floor. Ito yung floor. Okay. Yung joist, ito pala yung joist. Okay. Ito yung beam. Nakapatong kasi yung floor joist sa beam. Ito rin yung floor joist. The spacing is, ito yung spacing na 400. Okay. Ito naman yung span na 4 meters. Okay. So the tributary area for this one is 1/2 of this one. Okay, ito yung tributary area, which is also equal to 400 din to. Okay? If kung meron din tayong dito floor joist, ano? Ganon. Dito pa lang floor joist. Okay? Meron din tayong floor joist dito. So ang tributary area is this one. Okay? We just have to compute this tributary area. Okay. So what is the load with respect to itong 5 kilopascal na, okay, floor load? So for floor load, ano yan? 5 kilopascal or 5 kilonewton per square meter. Para maging uniform load siya, multiply mo lang siya ng 400 or 0.4 of a meter. Kung may calculator kayo, you can calculate, okay?
Sir, ask lang po.
Okay.
Yung given po doon nakalagay, effective span of 3 meters.
Oh, so 3 meters, sorry. Okay, thank you. That's 3 meters, sorry. Okay. 3 meters. Okay, very good. Thank you. Okay na? Okay na tayo dyan?
Okay na po, sir. Thank you po.
Okay. Very good. Okay, so 5 kilonewton meter squared or 5,000, pwede rin 5,000 newton per square meter. 5 times 0.4. Pwede natin gawin na lang ito 5,000 newton, no? Para maging newton meter tayo. Gusto ko kasi hindi masyado mataas. 5,000 kasi 1 kilonewton is 1,000 newton. Okay? Times 0.4 will give us, kung may calculator kayo, you can solve it. 5
Sir,
times
0.3 na po ba dapat yan?
Ha?
0.3.
Alin 0.3?
Yung
0.4.
multiply po.
0.4 meter kasi nag-compute natin sa tributary area. Yung tributary area. Ibig sabihin, i-consider lang natin itong kalahati dito. Ito yung kinocompute natin, okay? Kalahati dito at saka kalahati dito. This one corresponds to 0.4 also. Tingnan, if you're going to look at the top, ito yan, ano? Ito yung floor joist na 0.4. Ito yung span na 3 meters. Okay? So ito yung i-consider natin. So yung weight mo, i-multiply mo lang ng 0.4 will give you 2,000 Newton per meter. Ano to? Floor load pa lang to. Okay? Now, how about the weight of the wood? Weight of wood. Anong weight of wood? 6.3 kilonewton per cubic meter or 6,300 or 6.3 kilonewton, 6,300 newton cubic meter. Okay? Anong mo multiply natin dito? hindi natin isasala yung span kasi take note, this meter is already for the span. Ano? We are going to come up here a Newton meter. Ano? What is the section of the floor joist? 400 ito, 400, 75 by 200, sorry. 75 by 200. So 0.2 meter, convert na lang natin 200 divide 1,000 is 0.2, 75 divide 1,000 is 0.075 meter. So the answer for this one is 94.5. Tama ba? Check ko nga may nagsasagot dito.
Yes, sir. Tama po.
Okay. Wait lang kasi nanibago ako dito sa kung ibang dating ginagamit ko na yung ibang ginagamit ko dati na tawag nito na app. Okay. Okay. Wait lang. Okay, so what would be the total weight? Yung total weight na, so actually sum up lang naman natin yan. Weight is equal to 2,000 plus 94.5. So that becomes 2,094.5. 294.5 Newton meter. So we have already W. Pagka meron na tayong W, madali na siyang ma-compute. What is our moment? The formula actually is just equal to FB. Since this one is rectangular section, we can use 6M BD squared. Madali lang naman to eh. Okay? But first, let us compute moment. What is moment? This is a simply supported beam. Anong moment? WL squared over 8. Tama ba?
Yes.
Okay. So our W is 2,094.5 Newton meter. L is 3 meter. 3 meters squared over 8. Let us calculate. This one will become Newton meter, 2356. Tama ba?
Yes, sir.
356.3 Newton meter. Kung meron na tayong moment, madali na yung bending stress. Ang unang tanong, calculate the maximum bending stress. Take note sa mga simply supported beam, itong WL squared, itong moment na to, this is moment at the midspan. Okay? Pagka moment at the midspan, that would be the maximum. Wait lang Ito na. Ayun. Okay, good. Okay. Ayun. Okay. So therefore, we can now compute our stress. FB 6 moment is 2356.3 Newton meter. Dapat maging millimeter para megapascal na, Times mo ng 1,000, magiging millimeter na siya, Kasi 1 meter is equal to 1,000 millimeter. Millimeter na to, Kasi ganun yan, Cancel yung meter. Okay, Newton na siya. B, okay. Ano yung B natin? 200 by 1 na tayo, 200 by 75. Okay. B is 75 millimeter na tayo. D is 200 millimeter BD squared. Okay? So millimeter dito, makakancel yung isang millimeter, millimeter squared na lang ang matitira. So therefore, the unit here is Newton millimeter squared or megapascal. What's the answer? 4.71, tama ba?
Yes, sir.
So that is our, yan yung ano natin? Bending stress. Now, how about shearing stress? Actually, di ko pa nga na-discuss ngayon yung shearing stress. Anyway, ang formula kasi ng shearing stress, formula of shearing stress is, you have this general formula, VQ over IB. Ano? Anyway, di-discuss ko to in detail mamaya. No? Or, for rectangular section, we can use 3V over 2BD. Okay. What is our V? Okay. Pag ito yung beam, ano? Ito yung beam. Ito yung reaction. Ito yung reaction. I-draw ko muna para mas just a review. Ano? First problem pa lang natin. Next time din na tayo mag-isa-isa. This is W. The maximum shear for simply supported is the reaction itself. Ano? Ganito yung shear niya. Ano? Shear diagram. The shear here, V, is just also equal to R, which is also equal to, since this one is symmetrical beam, WL lang over 2. Tama? This is L. Di ba? So, V here is WL over 2. What is our W? Andito na, no? 2,094.5 Newton meter. L is 3 meters. Divide 2. Then we can have the value of V. Okay. 3141. Correct me, ano, kung may mali. Open your mic. Minsan di ko nababasa yung chat nyo. Okay naman. For 1.75 Newton. Okay, if we have V already, then we can substitute from here. So, FV is equal to 3V na 3141.75 Newton. Okay? Ito meter kayo na-cancel. Ano kaya Newton? I, 2BD. Ano? 2, what is B? 75 millimeters. What is D? 200 millimeters. So therefore, FV could be computed or equal to 0.31 Newton millimeter squared or megapascal. Okay? Any question about this one? Okay lang. Oh, if there's no question, we can proceed to second problem. Okay. Second problem tayo. Lagay ko lang to doon. Okay. Our second problem, you have here a timber beam having a simple span of 4 meters. Okay. Then you are carrying a total load including its own weight of 10 kilonewton meter. It has a width of 200 millimeter and a depth of 260 millimeter. Use dress dimension by reducing its dimension by 10 millimeter. Ano yung tinatawag na dress dimension? Pagka ano siya, yung smooth na, no? Pag smooth na siya, so siyempre magre-reduce ng 1 ng mga 10 millimeters. Ina-assume natin na that will reduce to 10 millimeters. Okay, so the same question, compute the flexural stress. So for example here, you have here our beam. Okay. The load is given equals to 10 kilonewton meter. The section, you have here 200 and 260. Ang tinatanong lang naman is flexural stress, ito 4 meter. Madali na, ano? You have FB, this is a rectangular section. This is equal to 200 and then 260. Pero sabi doon sa problem that it has to be reduced by 10 millimeter. Ano? Para maging dress dimension. Yung gagamitin na smooth na siya, no? Na kalimutan ko ang term sa English nun, yung na sewn na siya. This is 250 therefore, and this one 190 pagka-dress na millimeter. Okay, so you have here 6M BD squared. Okay, what is M? Ito lang naman, no? M is WL squared over 8. You have here W na 10 kilonewton meter over L na 4 meter squared, and then you have 8. So therefore, moment could be calculated equal to, tama ba? 20 kilonewton meter. Okay, tama ba? Let me check your chat. Okay, very good. Okay, let us substitute. Therefore, FB, you have 6 times, you have 20 kilonewton meter. Pagka kinonvert natin into Newton millimeter, we need to convert into Newton millimeter to have a result of megapascal. Ano? Multiply mo na lang 1 times 10 to the power of 6 para maging Newton millimeter. Okay? So, you have here B, ito, ano, 190. And then D squared, which is 250 millimeter squared. Okay? 1 millimeter will cancel out. So we can have here FB is equal to, kindly calculate also, 10 point, okay, megapascal. Well, let me check sa chat. Okay, it's correct. Okay, number 2. What is the flexure, maximum shearing stress? Okay, FV, ganun lang din, 3V over 2BD. V is just equal to the reaction, which is equal to WL over 2. Okay, ano yung WL over 2? This is just, ayan, 10 kilonewton meter. L is 4 meters over 2 versus 1, 2 will become 20 kilonewton. Okay, so we can substitute here FV is equal to 3V. 20 gawin nating Newton, 20,000 Newton. 2, B is already addressed, meaning 190 na lang. Then you have D 250. Okay, so FV is equal to 0.63 megapascal. Easy lang, ano? Any question? So far, none. Okay, okay, good. Then we have, okay, third question. Ngayon, we will have this triangular load. Okay. Let's have this triangular load. So we have here a cantilever beam. Again, we have 60 millimeter. Okay. This is the beam. Okay. Ito is 60. Ito naman is 200. All in millimeters. Okay. Now, this will carry a load that varies uniformly as you see here. Okay. Dito is 0. Dito naman is 1,000. Okay. 1,000 yan. So obviously, pag maka-cantilever beam, andito yung resisting moment. This will create an overturning moment due to the load. Halimbawa, ito yung resultant load, which is just equal to, ano to? Just the area of the triangle. 1/2 of 1,000 times 6. Tama ba? 6 divided 2 is 3. This is 3,000 Newton. Okay? Okay. Now, the moment arm is going here. Okay? Sa triangle, ano, the center of the triangle is just 1/3 of the length. So this is 1/3 of 6, which is, in other words, this is 2. So from here, we can compute the moment. No? Which will go straight to the calculation of moment. For all we know, the moment is necessary for the flexural stress. So you have here moment is equal to itong resultant na 3,000. 3,000 Newton multiplied by this moment arm na 2 meters. Ano? So you have here moment arm na 2 times 3 is 6,000 Newton meter. The question is to compute the magnitude and location of the maximum flexural stress. Obviously, the location of the maximum flexural stress is at the free end. Ano? Andito naman talaga. Even if you will try doing calculation by integration sa function of x, ano? Dito talaga yung maximum. Okay, so FB or flexural stress is 6m BD squared. 6 times ito, pwede ito maging 6 times 10 to the power of 6 na, ano? Newton millimeter. Kasi 6 times to the power of 3 Newton meter times 1,000 maging times 10 to the power of 6. O ito na lang, 6,000 times 1,000 become Newton millimeter. Okay? B. What is B? Ito, 60. What is D? 200 millimeter squared. Okay, so we can have FB here in terms of, okay, megapascal na. So the answer? 15, ano? 15 megapascal. Tama ba? Let me check. Okay, very good. Now, second question. Second question is to compute for, okay, determine the type and then the magnitude of the stress in a fiber 40 millimeter from the top of the beam at a section of 3 millimeters from the free end. So number 2, yung na-discuss ko kanina, no? Sinasabi na you are going to, okay, if this is the beam, no? At a span of 3 meters from the free end. So we are going to compute the moment here. Ano? Okay, so since this is 1,000, this is 6, this is y, this is 3, obviously it's 500, ano? Kahit mag-ratio proportion kayo kasi hati lang. 500 Newton per meter. Okay? So we can find here our resultant load. Lalagay ko muna ngayon, ano, para next time we can just go with the calculation. Resultant load is 1/2 of 500 kasi may iba naman na hindi nakakapag-catch up agad, no? For the benefit of to give opportunity learning to everyone. Okay, this one, if this is 3 meters, so obviously 1/3 of 3 is 1 meter. Okay, 1/2 of 500 times 3 meters. Okay, so this one will become 250 times 750. 750, ano unit? Newton meter. Okay? So our moment here is just equal to 750 Newton meter times 1 meter. Kasi ito yung moment arm na 1 meter. So moment is equal to 750 Newton meter. Squared to, ano? Newton na to pala. Sorry. Kasi tanggal na yung meter. Moment na to eh. Newton. Okay. So let's go substitute. But the question is, to determine the type and magnitude of the stress in a fiber 40 millimeters from the top of the beam. So ito yung beam mo, no? Ito yung beam mo na 200 and ito yung neutral axis. The distance of here, distance from here is 100 kasi total of 200. Ang tinatanong is just 40 millimeter from the top, 40 millimeters from the top of the beam. So yung 40 na yan, nandito yan. Okay? Ito yung 40. Ano? So ang tinatanong is only this location which has a C equals to ano yan? 60. C. So we can therefore use here, okay, MC over I. FB is equal to MC over I. We have moment, but we don't have yet I, but we can compute I, of course. You have BD cube over 12. Moment of inertia for rectangular section. B is equal to 60. D is equal to 200 over 12. So therefore, I is equal to 40. Tama ba? 40 times 10 to the power 6. Can they check?
Yes, sir. Tama po.
Very good. Okay. So we can now substitute here. FB is equal to M. Ando naman, ano? 750 Newton. Sorry. Newton meter multiply ng 1,000 para maging millimeter. Okay? That is just moment. C, andito na, 60 millimeters. I is 40. 6 ito, no? 40 times 10 to the power of 6 millimeter to the power of 4. So therefore, FB will be calculated as 1.125 megapascal.